Hi everyone, welcome back to Srihan Academy. So today's concept, derive an expression for electric potential due to an electric dipole at any point. So first we need to see here what is an electric dipole. So first that we need to draw the diagram. So electric dipole means two equal and opposite charges separated by set and distance 2a. So that's called electric dipole. So first we'll mention here it is minus q we can take here, and it is the plus q, and distance it is the 2a. So we can imagine these 2 points a and b, and we need to choose one point p somewhere here to calculate the electric potential at a distance r from center of the dipole. At any one point we can choose here at a distance smaller from center of the dipole. It is the distance r, so we can choose this is on center point O, and this is the point P where we are calculating electric potential due to dipole. And this side distance is the a, and this side it is the a, and this angle we can take it is the theta. And what is the distance from positive charge to point P and a negative charge to point P means we can imagine some distances. Actually we don't know these distances here, we need to assume that r1 and r2. So if you take this is the r2 here from negative charge and r1 from positive charge. So how to calculate this? First r1 and r2 later I'll explain. First we need to write the electric potential due to positive charge and due to negative charge. So first we'll write this, the electric potential at P due to plus Q is V1 is equal to 1 by 4 pi epsilon naught Q by R1, and next due to negative charge. So the potential at P due to minus Q. As we know the concepts here, negative charges gives negative potentials and positive charges gives positive potential. So here due to negative charge means negative potential will come. So that's why written here minus 1 by 4 pi epsilon naught Q by R2. Now what is the total potential at point P? Total potential at P, V is equal to V1 plus V2. So now we can write this, V is equal to 1 by 4 pi epsilon naught Q by R1 minus 1 by 4 pi epsilon naught Q by R2. Sorry. Now we can write this common term, Q by 4 pi epsilon naught we can take out, and into 1 by R1 minus 1 by R2. Actually we don't know what is R1 and R2, that we need to calculate here. So we'll extend this one line here. This is the extended line here we can imagine, and we can draw the one normal line from point B to OP. So we can calculate here also, and we can draw the one more line from point A, and we can imagine this is the right angle triangles concepts we need to imagine here. So this is the point C we can imagine right angle, and this is on point D we can imagine here it is also right angle here. Now what is the values? First we'll take here from the triangle AOC, from the triangle AOC. So cos theta is equal to, so how much, what is angle here sir means this is the theta, because this side is angle theta means this side also is angle theta only, similar triangles concept. So cos theta is equal to adjacent means here OC by OA. So OC is nothing, we need to calculate, by OA is nothing but A. So from here OC is equal to A cos theta. And the next another triangle also we can use here, triangle BOD. From here cos theta is equal to, again we need to apply here, so adjacent by hypotenuse. What is adjacent here? It is OD. So OD by OB, so is equal to, OD is equal to, will get A cos theta. So from the diagram here, R1 is equal to, it is similar to CP. So okay, so R1 is equal to Cp, that is equal to OP plus OC. So OP means it is a nothing but R plus, sorry, it is R2, sorry, R2. R2 is equal to Cp, that is equal to OP plus OC. So that is the R plus A cos theta. And then what is the R1 is represents here means dP from the diagram. So that is equal to OP minus OD. OP minus OD. OP is nothing but R and OD is nothing but A cos theta. So this is the R1 and R2 values. Now we can substitute directly in the above equation. V is equal to Q by 4 pi epsilon naught into 1 by R1 means here R minus A cos theta minus 1 by R plus A cos theta. So now we can take the LCM here. V is equal to Q by 4 pi epsilon naught into, so R plus A cos theta will come here, minus of R minus A cos theta whole divided by A minus B into A plus B concept, A square minus B square, so A square cos square theta become this. Now again if I extended this, V is equal to Q by 4 pi epsilon naught into R plus A cos theta. So minus, if you multiply minus R plus A cos theta will come here, minus into minus plus by R square minus A square cos square theta. So this plus R and minus R will get cancelled here. So then V is equal to Q by 4 pi epsilon naught into 2A into cos theta whole divided by R square minus A square cos square theta. So this is the concept here. Now we take R is much greater than A. So R square minus A square cos square theta is approximately equal to R square. So then we can write this, and one more concept also we need to write here. P is equal to Q into 2A in the numerator. So we can write this 1 by 4 pi epsilon naught do P cos theta by R square we can write here. So this is our final expression, and how that potential is related with the distance due to dipole means it is inversely proportional to square of the distance. So this is the concept here, and we can write this axial line and equatorial line also. That means if theta is equal to 0 degree, cos 0 is 1, so we will get it is a 1 by 4 pi epsilon naught P by R square. If theta is equal to 90 degrees and cos 90 is 0 degrees, so that means potential is 0 at equatorial point. If you take minus Q plus Q and this condition, and here it is the minus Q and plus Q if you take one point P here. So these conditions. So hope you understood, students. Thank you all.